Hello my scholars, welcome to my school YouTube channel. My name is Emmanuel and in today's video we'll continue solving JAMB CBT past question for chemistry in the year 2006. Please don't go anywhere, stick around and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we'll continue with question 26 to 50. Now let's get down to question number 26. A difference between chemical and physical change is that in a chemical change, first of all, we must know that a physical change is a type of change that occurs whenever substances, two or more substances, react together, to form a substance that is easily reversible. In other words, we are saying that when those substances are formed, there is no new substance that is formed because it is easily reversible. While in chemical change, a chemical change will occur whenever substances react together and then a new substance is formed. We have a new substance entirely formed that is not easily reversible. Back to it. For instance, when we talk about physical change, when we put ice, ice block in water, of course it can melt, and then it eventually turns to ordinary water. If you put that back into the freezer, you can get your ice block back. So that is a physical change because it is easily reversible and that is no new substance. But if you get your firewood, and then you make a bonfire of it and then it turns into charcoal and ashes, you discover that you cannot get your charcoal and the ashes back. Even though you put them together, you can't get your firewood back. So that is a chemical change. So now the question says that the difference between chemical and physical change is that in a chemical change, option A says oxygen is consumed depending on the reaction, option C says B says it is supplied, option C says a reversible process occurs. And then of course in a chemical change it is irreversible, like I gave you example of firewood. And option D says a new substance is formed. Of course, definitely in a chemical change, new substances are usually formed that are not easily reversible. So the correct answer is option D. Question 27. The volume of 2.5 moles of oxygen at STP, standard temperature pressure, is what? Molar volume of a gas at STP is 22.4 dmK. Well, they say there are different ways of killing a rat. So we have different approaches to solving of this. But you go for the easier one or the easiest one. Let's look at the board and see the first approach. It says the volume of 2.5 moles of oxygen. So the molar volume of a gas at STP is 22.4 dm3. In other words, it's saying that if 1 mole of gas, of course that's oxygen gas, gives 22.4 dm3. That's what we're giving. That's the molar volume at STP. At STP gives that. So the question says the volume of 2.5 moles. So then we have to, this is 1 mole. So that means 2.5 moles, of oxygen will give what? Will give X. So if you cross multiply, you will just have 1 times X will be equal to X. Then we have 2.5 moles times what? 22.4. So by the time you multiply this together, 2.5 times 24, you shall be having around that should be 56 dm3. So that is one approach. Alternatively, you can use the formula method. You can use the formula method saying that number of moles, because we know we are giving number of moles to be equal to 2.5 moles, and then we're giving also molar volume at STP, which is a constant 22.4 dm3, and then you will have to find what? Volume. So there's a relationship between these three, which is number of moles equals to volume over what? Molar volume. For what? Gases, number of moles. So number of moles is 2.5. We just have 2.5 here will be equal to volume. That's what we want to find. Over molar volume is what? 22.4. So by the time you cross multiply, 1 times V, volume will be equal to what? 2.5 times 22.4. So by the time you multiply this together, you should have 56.0 dm3. Just like we have it. So whichever one is suitable for you, go ahead and choose. Let's go to the screen to see what we have. Option A says 50 dm3, 84, 28 and 50. So the correct answer is option D, 56 dm³. Question 28. Nuclear fission involves the splitting of a heavy element into two nuclei. This is what? Fission. Okay, we have what we call nuclear fission and we have nuclear fusion. Okay, when you have fusion, F-U-S-I-O-N, so there's fusing. So which means we have two light elements, okay, two light nucleus or an atom or substances reacting together, okay, to form a heavier one. Okay, but in this case now, nuclear fission, it has to do with what? Splitting. Okay, there's the nuclear fission. Okay, there's the breaking of or splitting of a heavy element, okay, atom of an element into two nuclei. Usually those two nuclei, they have masses, okay, that are almost the same. They have masses that are almost the same. When we talk about almost the same, their masses are almost the same because there's a larger one that has been split into, and usually whenever, because it's a nuclear reaction, usually there will be radiation, and more than that, there will be what? Energy will be given off. It is a nuclear reaction. Okay, so we have option A says we have nearly equal masses, yes, with a release of energy, yes, and then radiation for sure. That is more likely. Let's look at other options. Option C says equal masses with a release of energy. In most cases, we don't have equal masses in most cases. Okay, so this will not be. There's a release of energy, yes, but the masses are not always. Option C says equal masses with a release of energy and radiation. Of course, this looks like this, but this is nearly equal masses. Okay, but this is what? Equal masses. So the masses of the nuclei of the atom of the element that are split into are not the same. Okay, option D says unequal masses without any release of energy. There must be a release of energy because it is a nuclear reaction, okay, that undergoes radiation. So option A, which says nearly equal masses with a release of energy and radiation, is the correct answer. Option A is the correct answer. Question number 29. What is the molar mass of a substance if 0.4 mole of the substance has a mass of 25.0 gram? Let's move on to the board. What is the molar mass of a substance? Usually, like I often say, that whatever parameters you are given, you should write it out. Okay, we're asked to find what is the molar mass of a substance. So I will write here molar mass is question mark. That's what we want to find. If 0.4 mole of the substance, which means number of mole is 0.4 mole, okay, of the substance, and then we're also told that has a mass of 25 grams. So the mass is 25.0 gram. Of course, this is so easy, just like we know that there's one relationship between number of moles, mass, and molar mass. So to find the amount of a substance or number of moles of a substance, we say number of moles is equal to what? Mass over molar mass. Okay, so which is equal to we have mass, number of moles we're given to be 0.4, so we have 0.4 here, then mass is actually what? 25 gram. Then all over molar mass, that is what we intend what getting. So by the time you make this over 1 cross multiply, we have 0.4 m equal to 1 times 25. We have 25 grams. So we divide both sides by 0.4 by 0.4, so that a molar mass should be 25, of course, divided by 0.4, okay, which is 25 multiplied by, you can still have it as divided by 0.4, that is a 4 over 10, okay, 4 over 10, yeah, so that should be equal to 25 times 10 over 4. Of course, if you have a calculator, you just punch this. So we have, of course, 2 goes here, 2 goes here, that's 5. So we have 25 times 5 divided by 2. 25 by 5, 5 is 5, that is 25, 5, 2. That is 5 times 6, that's 10, 1 to 5. So 1 to 5 over 2 gives us 2 in 12, that is 6. In this, that is 2. Then we have 0.1, okay, remainder 1. So that is 1 over 2 is 0.5. So we have 62.5, okay, gram per mole. Of course, that should be the molar mass of the substance. Let's look at the options we have on the screen. Okay, option A says 62.5 grams. So the correct answer is option A. Question 30. The element with the electron configuration 1s2, 2s2, 2p3 is what? This, you don't need to waste much time on this. So all you need to do is what? You just add up this. This is what shows the number of electrons on each of the orbitals, okay? So we just add 2 plus 2, that is 4, 4 plus 3, that is 7. So you ask, what element has the atomic number 7? Okay, so usually, I know of course it's nitrogen. So we have let's see, option A says calcium. Calcium has atomic number of 20. Okay, so it is not that. Chlorine has atomic number of 17 in the periodic table, so that is not it. Oxygen has atomic number of 8. Yeah, so that is not, of course, in group 6. Yes, 8. So which means it is not it. And nitrogen has atomic number of what? Of 7. So 2 plus 2 plus 3 is 7. So the correct answer is option D. Now on to question number 31. A decrease in atomic size and an increase in nuclear charge across a period lead to what? Now usually when we talk about atomic sizes, as you move across the period, okay, in a periodic table, okay, usually the atomic sizes decreases. Why? Because there's going to be an increase in the effective nuclear charge, okay, of the elements that are in that, and that is as a result of what? Addition of what? Proton. As you are moving across the periodic table, don't forget that what happens, the atomic number increases, and the atomic number is as a result of what? Proton. So as number of protons are increasing, okay, it tends to make for a kind of strong attraction, force of attraction now, between the proton that is in the nucleus and then the electron that is revolving round what? The orbit, or already the shell that has been in the atom of that element. So in other words, we are saying a decrease in atomic size usually will occur as you move across the periods, okay, because the number of protons are increasing, which variably increases what? The effective nuclear charge, okay. And once that happens, it tends to increase what? The type of bonding, okay, the strong force of attraction between the proton that is in the nucleus, okay, together with what? The electron that is revolving around the orbit of that. So that, of course, is going to lead to, option A says, an increase in the tendency to lose electron. No, if the atomic size is increasing, okay, and the nuclear charge is increasing as we move across the period, we are meant to have what? We are meant to have a decrease. It is going to lead to a decrease in the tendency of the electrons to be lost, because as you are moving across, it is easier for the one that is first, okay, to lose electrons, and then those ones that are, so the loss of electron, tendency to lose electron begin to decrease as you are moving across the period. So option A is not correct. Option B says an increase in chemical reactivity. Well, depending on the type of reaction, depending on the type of element, okay, and the condition, that will determine if it's going to increase or if it's going to decrease the chemical reactivity. Option C says a decrease in electropositivity. Yes, because as you are moving across the period, don't forget that elements in group 1, still on that period, okay, they are alkali metals, okay, which are the most reactive metals. Then we have the alkali metals in group 2, even though they are in the period, but those periods, those elements belong to the different periods in the periodic table. So of course, as you are moving across, the electropositivity decreases, and then electronegativity increases, because as you are moving away across from the period, you are tending towards the electronegativity of the element. You are moving towards the elements from metals to non-metals, okay, like that to gas. So there's going to be a decrease in electropositivity, of course, because there's a decrease in atomic size and an increase in nuclear charge across the period is going to lead to a decrease in electropositivity. Yes, option D says a decrease in covalency in bond. In fact, a decrease in atomic size is supposed to favor more bonding, okay, more covalency in bonding. It should not be decreased. It should increase the covalency in bond formation. So as a result of that, the correct answer is option C, a decrease in electropositivity. Now let's move on to question number 32. The order in which a mixture of sand, ammonium chloride, and sodium chloride can be separated is what? This is mixture, okay? We talked about this in one of our video lessons in chemistry, so you can subscribe to look at separation techniques, okay? So usually whenever you want to separate, because this is mixture, okay, you want to separate, you must look at the type of substances that make up that mixture. That will determine the approach, the technique to use. Now we have sand here, we have ammonium chloride, and then we have sodium chloride. Of course, you agree with me that sodium chloride is a soluble salt, okay? If you dissolve it in water, you are going to have it dissolve, okay? And then you have ammonium chloride. Ammonium chloride is a sublimable salt, okay? If you apply it, it will sublime, okay? Even though it is solid, it can change from solid to what? To gaseous state, okay? And then we have sand here. Of course, sand is insoluble. So first thing to do is, this is insoluble, this is soluble, okay, in water, but this one is sublimable. So first, we need to deal with this one first, ammonium chloride. All you need to do is get the mixture, put it in a china dish, okay? When you put it in a china dish, of course, there's a plug that you have to it. So you apply, there's a funnel, and then you have a cotton wool on that place. So as you apply it, what happens? Ammonium chloride begins to what? To sublime, to escape, and then it is collected, of course. As it cools, on cooling, it forms around what? The funnel. So you can be able to what? To separate your ammonium chloride that way. So what we are left with now is your sodium chloride and what? And sand. So it's easy. Add water. When you add water into this, what happens? And stir. As you stir, what happens? The sodium chloride what? Will dissolve in the water, while sand remains on the surface. So you filter off. When you filter, what happens? You have your sand separated. The water is already, this one is already in the solution, okay? So you can now apply it. So you separate the solution of sodium chloride and then the sand. So what you are left with the sodium chloride. So when you apply it to sodium chloride, what happens? You have what? You have your what? Crystals of what? Sodium chloride. So you have been able to separate them. So option A says dissolution. You are not going to dissolve first because we must deal with this ammonium chloride. So this makes option A to be what? To be eliminated. So don't waste your time going through this. This solution, you can't start with solution option because it says the order. So which one comes first before the other one? So the other one says filtration. We can't start with filtration because we must deal with ammonium chloride first, which is sublimable, okay? Option C says sublimation. Yes, sublimation because of ammonium chloride. And then the next one we have dissolution. Yes, because you add water to dissolve sodium chloride. And then we have filtration. You filter off your sand and eventually you apply it so that you can get your what? Sodium chloride from the solution. So which means option C is correct. Option D says dissolution. We can't start with dissolution. That's just sublimation. So the correct answer is option C. Now let's move on to question number 33. The idea of planetary electron was that of who? We have Rutherford, we have Thomson, we have Neil Bohr, that's Bohr, we have Dalton. Yes, this is a controversial question, okay? Usually, now let's analyze it now. Ernest Rutherford in the year 1911 was the first scientist to come up with the idea of planetary what? Electrons. He said that electrons can what? Can revolve, okay? Can keep revolving around what? The nucleus, okay? Of an atom, of an element. So it keeps moving on in orbit and then moving on in planetary like that. So it was Rutherford in the year 1911. Then in year 1913, because debate is always between Rutherford and Bohr. So of course, not Thomson, not that. So, but in year, like I said, in year 1911, Rutherford was the first person to come up with it. He came up with the idea that electrons can begin to what? Revolve in planetary, form, okay? In then around the what? The nucleus of the atom of an element. Then in 1913, Niels Bohr now redefined, okay? And then now worked on it again. To when he worked on it, he now came up with the fact that, oh, actually, those electrons that are revolving around the orbit, they can be in shells. Like we have the K shell, the L, M, and N. Okay, so which means that this was in 1913, this was in 1911. So the idea of planetary electron was that of, so the first person that, yes, it was Niels Bohr that redefined it and said, okay, electrons can move, from K shell to from talking about the different energy levels, okay, where electrons can revolve around. But the first person to actually work on it, that came up with the idea of planetary electron, is actually Ernest Rutherford. So based on that, the correct answer is option A, Rutherford. Question 34. If 30 cm cube of gas at 50 degrees Celsius is warmed to 80 degrees Celsius, so we have initial temperature, final temperature, okay, at a fixed pressure. So what it means is that pressure is kept constant. And what is the relationship between volume and temperature? That is your Charles' law. And Charles' law states that the volume of a given mass of gas is directly proportional to the to temperature, provided that pressure remains what? Constant. Pressure remains constant. We dealt about that in one of our video lessons, gas law. So please subscribe so that you can have a full knowledge of how to go about questions like this. But let's go look at this question. So the question says that the fractional increase in volume is what? Now there are two things we are going to do here. First, we have initial volume here, that's V1, and then we have T1. Let's look at it. Let's go to the board. We're given the parameters. We have volume. Okay, that is V1 is actually 30 cm cube. Then we're given the temperature, that is T1 is actually 50 degrees Celsius, and then we're given T2 should be equal to 80 degrees Celsius. Okay, and then we're asked to find what? Increase, fractional increase. So now, before we talk about fractional increase, there are two things there. So first, we need to find the increase first. Then before we talk about what? Fractional increase. There are two things. They are not the same. First, you talk about what? The increase first. So the increase, and you cannot get the increase without getting what? V2 first. So we must get our V2 first. So when we get our V2, then we talk about the increase. And increase, you know, is what? V2 minus what? V1. That's how you know what the increase in volume is. So we are going to find that. Then when we talk about fractional, fraction is, of course, when you talk about fractional, you're talking about what? There should be a numerator, there should be a denominator. So fractional increase. So which means the increase, of course, let's analyze this before we begin to solve. Fractional increase in volume, not in temperature. In volume, we mean that the increase in volume, which is V1 minus V2, okay, fractional, okay, divided by what? The initial volume. So this is going to be a fractional increase. So this is where we are coming to eventually. So let's take it gradually, step by step now. So the first thing is what? Let's get our V2 first, because we know our V1 here. So we need to get what our V2 is. So V2, of course, relationship, like we said, pressure is constant. So which means the relationship between what? Volume and temperature. So that which was according to Charles' law, according to Charles' law, okay, Charles' law, the volume, okay, is what? Directly proportional to what? To temperature, okay, at constant pressure. Okay, so which means V is actually equal to, if we move this because it equals to KT, so that we have what? Divide both sides by what? By T. So V over T is equal to K. I want to appreciate how the volume was derived. So V over T is equal to that. So that's how we came up with V1 over T1 equal to V2 over T2. So if we move on, how we move on to this point, V1 over T1 equals to V2 over T2. We're given our V1 already. V1 was actually 30, so we say 30 here, okay, over T1, that's initial temperature. Now, don't forget that this is actually in degrees Celsius. So in temperature, because we talk about absolute temperature in Charles' law, so we must convert this to what? To Kelvin. So what do? We had 273. We had 273 there. Then also this we had 273. So when you had 273 to this, that will be 3. 7 plus 5, that's 12. 2, 1 plus 1, that's 3. So 323 Kelvin. Then we had this to this, that's 3. We have 7 plus that's 15. 1 plus this, that's 3. So 353 Kelvin. So we have V1 over T1. T1 is what? 323. Okay, Kelvin, equal to V2, that is unknown, over T2 is what? 353. So by the time we cross multiply, we have 323 V2 is equal to 30 times 353. Okay, so that V2 will be equal to 30 times 353 divided by 323. So that V2 eventually is going to be 32.79. okay, so that's going to be cm cube. So that's what our V2 is. So if V2 is that, so the increase now will be increase in volume, which is actually V2 minus V1 will be equal to, V2 is what? 32. Okay, I'll just have that here. It will be 32.79 minus V1 is 30. So by the time you subtract that, we have around 2.79. Okay, 2.79 is what we have here, cm cube. So that's the increase. So, but we are talking about what? fractional increase, and we said the fractional increase should be V2 minus V1 over what? V1. So which means we have V2 minus V1 already, we had it to be 2.79, okay, divided by V1 is actually 30. So by the time you punch your calculator, you should have 0.092, okay, 28 and so on and so forth. So we have that there. So we have 0.0928. So by the time you round this up, of course, we have 0.09 approximately 3. 0.093. So this should be the fractional increase in volume. Okay, if we have to just find the new volume, we would have just stopped at what? V2, which is this. If we have to find the increase in volume, you just say V2 minus V1, which is this. But we're told to find the fractional increase in volume, which is 0.093. So let's move on to the screen. The option we have here, the one that best fits in, is actually option B, 0.093. So the correct answer is option B. Do you know you can take practice questions on our simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool app on your Androids and the Myschool software on your laptops and computers. Please go ahead and start practicing. Now let's move on to question number 35. We have a chemical reaction here, C2H2O2, okay, plus this. So first we need to check to be sure that it's balanced, okay. We have 2 times 2, that is 4 for carbon here. Then we have 4 moles of carbon. We have hydrogen is 4 here. Hydrogen is 4 here, okay. Oxygen is 10 here. And then oxygen is 4 times 2, that's 8. 8 plus 2 here, that's 10. So the reaction is actually balanced. So in the reaction above, the mass of carbon 4 oxide produced on burning 78 grams of ethane is what? This is your ethane reacting with this. Of course, this is what we call what? Combustion reaction. Whenever hydrocarbon, okay, is reacted in air, complete combustion, that's by oxygen, 2 products are usually formed, carbon 4 oxide and water. Those are the products of combustion reaction of hydrocarbon, carbon 4 oxide and this. So we want to check now, what is the mass of carbon 4 oxide that is produced on burning? So let's move on to the board. We have, from that reaction, I will write this C2H2, okay, reacting with 5 moles of oxygen, okay, to give us 4 moles of CO2, carbon 4 oxide, and then we have water, of course, 2H2O, okay. So the question says, in the reaction above, the mass of carbon 4 oxide produced on burning, carbon 4 oxide produced on burning of what? 78 grams of what? Ethane. So what we are considering is between ethane and what? And carbon 4 oxide. So first of all, stoichiometrically we look at the number of moles. So we have for this and this, okay. So how much of this? So if we have 2 moles from this, that's why I said first ensure that the chemical reaction is what? Equation is what? Is balanced first, because you need that here. So we have 2 moles. So if 2 moles of ethane produces 4 moles of carbon 4 oxide, we're told from the question that the mass of carbon 4 oxide is what we want to find, that is produced on burning 78 grams of ethane. 78 grams of ethane. So don't forget that we know that number of moles is actually equal to mass over what? Over molar mass, okay? So we're told already that the molar mass, the mass of ethane was given to be what? 78, okay? 78 over what is the molar mass of ethane? Of course, you can solve that out. Ethane is C2H2, okay? Carbon is 12, okay, times 2, that's that. Then plus hydrogen is 1, then times 2. So this is 24 plus 1 times 2, that's 2, that we have 26. So which means that we have 24 plus 2 here, that's 26. So the molar mass of ethane is actually what? 26. Okay, so that means 78 divided by 26, that should be around 3 moles. Okay, so in other words, we are saying that because we're giving, when you look at the reaction, from the reaction stoichiometrically, 2 moles of ethane is meant to produce 4 moles of carbon 4 oxide. So they're asking us now, what mass will be formed if of CO2 will be formed if 78 grams of ethane, okay, reacted. So if 78 grams of ethane react, can we get the number of moles of ethane? Because we are looking at the what? The mole ratio now. If 2 moles gave 4 moles, what moles, okay, we give what mole here. Then from that we can get what our mass should be of this carbon dioxide to be formed. So we're told that already 78 gram of this of ethane reacted, okay, in the reaction. So divide with the mass, which is 78, by the molar mass of ethane, C2H2, we have 26. So which means gives us what? 3 moles. So which means, in other words, if 2 moles of ethane produces 4 moles, then 3 moles of ethane, okay, will produce what? X mole. Of course, this should be what? 6 moles. I hope no one is asking me how we got the 6 moles, okay? Of course, if this were X, if you cross multiply, okay, 2 times X will be 2X, then this time this is 12. 12 divided by 6, we have that. Of course, we have, look at the ratio. Ratio 2 is to 4. If ratio 2 is to 4, then it will be ratio 3 is to what? The sequence. So 3 moles of this is meant to produce what? 6 moles of what? Carbon dioxide. Now, the question did not say we should find the number of moles. The question said we should find what? The mass of that. But we know also, just like we did here, moles, which is what? Number of moles is actually equal to what? Mass over what? Over molar mass. Okay, we already know what the mass is. The number of moles is, which is 6. So we say 6 here is equal to the mass. That is unknown. That's what we were asked to find. Divided by the molar mass of carbon dioxide, CO2. Of course, that is 44. Okay, in case you are doubting, you can work it out. CO2, carbon is 12 plus oxygen is what? 16. But we have times 2 here. Okay, so that is 32. 12 plus 32 gives us 44. So we have 44. So that is 44. So if we have mass, will be equal to 6 times 44. If you multiply this, the mass of this is meant to be, that is 4. That is 224 plus this, that 26. 264 gram of this carbon dioxide. So in other words, 78 gram of ethane will produce 264 gram of carbon dioxide. Let's look at the screen. 264 gram, option A, say 264. So the correct answer is option A. I believe you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Question 36. The ion that can be used as an oxidizing agent is what? Okay, usually we know that non-metals are oxidizing agents. We know that metals are reducing agents. Okay, so all we need to do, there's no point wasting time here. Look at all the options we have here. Option A says Au3+. Au is your what? Your gold. Okay, we have metallic gold here, even though it's a noble metal, just like your silver. Okay, but it is a metal. So this is gold metal. So this is meant to be a reducing agent. Yes, we know that gold have low reactivity when it comes to oxidation, okay, and going to corrosion. Okay, that's why we call them noble gases, but it is a metal. So we know that generally metals are what? Are reducing agents, but we are talking about what? Oxidizing agents. So option A is eliminated. Option B is Fe3+, that is ion, Fe3+. This is also what? A reducing agent. So this one is also eliminated. Option C, we have Cl, this is chlorate, okay, ion. You can see we have a negative one here, and then of course this is a radical, but this is negative. Then look at this one, calcium ion is also what? A metal, which is what? Positively charged, is reducing agent. So among this now, this one is the only one that is what? That is an oxidizing agent, because they always what? Receive electrons that will be shared. So the correct answer is option C. Now let's move on to question number 37. H2 plus Br2 plus this gives this. Okay, now the above reaction is carried out at 25 degrees Celsius. Delta H is negative 72 kilojoules per mole, and delta S is negative, of course, delta H, that's the enthalpy change. We have delta S, that is the entropy change. Okay, the reaction will what? Will, option A says, not proceed spontaneously at the given, proceed spontaneously. So that means we are looking at what? The spontaneity of a reaction. And when we talk about spontaneity of a reaction, 3 conditions usually are responsible for the spontaneity of a reaction. Option, the first one, let's look at the board. For any reaction to be spontaneous, okay, for any reaction to be spontaneous, we must have delta G must be negative, delta H, okay, must be negative, and delta S, of course, should be positive. Okay, so these three conditions must be met for any reaction to be what? To be spontaneous. Delta G, which is change in the free Gibbs free, okay, free energy, is negative. Delta H is negative, and then delta S must be positive. So we were given already that the temperature actually is okay, let me just write this. Temperature is 25 degrees Celsius. Then we were given also that delta H is negative. Sorry, that is negative 72 kilojoules. Okay, kilojoules per mole. Okay, and that is all. Then we're given that delta S is actually equals to negative 106 what? Joules per mole per Kelvin. Okay, so usually we know that there's a relationship between them, that delta G is actually equal to delta H minus T delta S. Okay, delta H minus T delta S. So we have this to be equals to, we have delta H was given to be negative 72. We have that here minus temperature. We have to convert this to what? Kelvin. So because that's the what? The standard temperature. That should be what? The temperature, absolute temperature. So if we add this to this, we have that should be 298 Kelvin. So we have 298 here. Kelvin, of course, can have this multiplied by this is what? Negative 106. Okay, so by the time you multiply this, we have negative 72 minus times minus, you have a positive value. Okay, this is 106, yes, joules. Now you have to be careful here. We are giving this in kilojoules per mole, and then the delta S is in joules, so you have to convert this also to what? To kilojoules per mole. So all you need to do is what? Divide this by what? By 1000. If you divide this by 1000, we are going to have 0.106, yes, kilojoules per mole. So they must be in the same what? In the same unit as this. So this is 0.106. Okay, so by the time you multiply this, you have this. So negative that, you have it. So if you multiply 298 by 0.106, if you punch that on your calculator, you have 31.588. Okay, 31.588. So by the time you subtract this from this, you have you should have a negative value. Let's see, 72 minus 31.588. Okay, you should be having 30 something around that. Punch that in your calculator, you have 40. Okay, we have 40.412. Okay, 40.412 kilojoules. Okay, yeah, per mole. So actually, what we have here is what? Delta G, which is a negative value. Remember that the condition for spontaneity of a reaction is that what? Delta G must be what? Must be negative. So the delta G, which is the free energy that we have here, is actually a negative value. So which means this is what? A spontaneous reaction. Let's move on back to the screen. Option A says, I said the reaction with option A says not proceed spontaneously at the given temperature. Of course, it is spontaneous because we had a value for delta G to be what? Negative. Option B says proceed spontaneously at the given temperature. Of course, option B is correct. Option C says proceed in the reverse direction at the given temperature. No. Option D says proceed spontaneously at lower temperature. The correct answer is to proceed spontaneously at the given temperature because we have delta G to be negative. So the correct answer is option B. Now question number 38. Zinc and carbon rods are used as anode and cathode respectively in a what? Of course, we use that in the cell. Okay, you know we have electrochemical cell, we have electrolytic cell. You must know the difference between the two of them. Okay, so when we talk about cell, usually we know that two cells will make a battery. Okay, they transform chemical energy into what? Electrical energy. We use that. That's what cells do. So with first one, we're talking about Leclanche cell. We have the lead accumulator. We have Daniel cell. We have voltaic what cell? Usually the zinc and cathode rods, okay, are used as we have the zinc at the anode and then we have carbon at the cathode for usually what we call the Leclanche cell. You know, in the Leclanche cell, the zinc is always the anode while the carbon is always what? Because it is what? It is not reactive. It is always the cathode that we have as the what? At the carbon. And usually the electrolyte is ammonium chloride. Okay, the paste of ammonium chloride is what is used as the electrolyte in that. So if it is for Daniel said, it should have been zinc and copper. Okay, so the correct answer here actually is Leclanche said option A is the correct answer. Question 39. The solution that will conduct the highest amount of electricity is what? When we talk about highest amount of electricity, we are talking about the number of course, the strength of that acid. If you look at this, we have 0.5 mole per dm cube of hydrochloric acid, 2.0 mole per dm cube of hydrochloric acid, 0.5 mole per dm cube ethanoic acid, 2.0 mole per dm cube ethanoic acid. So if you look at the types of acid we have here, this is the same as this. So this is a strong acid. HCl is a strong acid, as you know, against ethanoic acid that we have here, which is a weak acid, because it does not dissociate completely when dissolved in water. But for this being a strong acid, when we add them, dissociate completely when dissolved in water. Okay, all the hydrogen ion are completely dissociated. So when we are looking at the one that conducts the highest amount of electricity is going to be a strong acid. So based on that, this is a weak acid, this is a weak acid. Forget about the concentration now for this being a weak acid. So option C and option D are eliminated. So we have the contention that is between option A and option B now. Now option A is hydrochloric acid, but the concentration is 0.5 and option B is 2.0. So this one has more concentration than this. So more concentration is meaning that what? We have more ions present, okay, that can migrate easily to form what? More electricity. So which means the one with higher concentration actually, even though it's a strong acid, both of them are the same, but with different what? Concentration. So the one that has higher concentration will do what? Will conduct more amount, will give more amount or produce more amount of electricity. So based on that, 2.0 mole per dm cube of hydrochloric acid, option B is the correct answer. Now let's move on to question number 40. In which of the following is the oxidation number of sulfur equal to -2, -2? Option A says SO3. Of course, if you know your oxidation state very well, SO3, you should know that sulfur here should be around 6, okay, because it's structure for sulfur. That, let's see, that will be this. Okay, let's move on to the board and let's see what it is. SO3, okay, SO3 here, of course, this is a compound at the free state, so this will be equal to 0. We want to determine the oxidation state of sulfur here. Sulfur here plus O3, okay, will be equal to 0. Sulfur plus oxygen is actually -2, so we have -2 here, then times 3. So we have times 3 here equal to 0. So sulfur is plus times minus is minus. 2 times 3 is 6 equals to 0. So sulfur is actually equals to what? +6. If you look at the second one, we have S8, okay? So that is actually the atomic state of what? Of sulfur, S8, of course. In the free state, the element, the atom of an element, the oxidation state of an element is always equals to 0. So it is 0 at this point, okay? Then the third option says H2S. H2S here, so we equate this to be equal to what? 0. Don't forget that hydrogen is actually +1, so we have +1 multiplied by 2, okay, then we have plus what? Plus S equal to 0. This is what? +2, then plus S equal to 0. So S will be equal to, transfer that, because what? -2. So which is what we have. So there's no point. SO2, let's just do that for benefit of that. SO2 is the last one, which is equal to 0. Sulfur plus, this is -2 times 2, that gives us 0. So that is -4 equals to 0. So S equals to what? +4. So which means that where sulfur is -2, -2 is actually in H2S. If you look at the option we have on the screen, H2S is actually option C. So the correct answer is option C, H2S. Now on to question number 41. In the electrolysis of copper sulfate using platinum electrodes, the reaction at the anode is what? Usually in the electrolysis of copper sulfate, usually we have, when a platinum electrode is used, we have the copper ions, okay, copper, that's Cu2 plus, will be reduced to what? The copper, solid copper metal, okay, that we're going to have in the reaction, okay. So which means that if it is reduced to copper metal, so which means that from +2 at the cathode, +2 that was the charge would have been what? Become what? 0. So which means there's what? Decrease in what? So which means there's a reduction taking place at the cathode, okay, for this reaction, while at the anode, water will be oxidized, okay, to produce oxygen, as well as hydrogen ion will be formed at the what? At the anode. Okay, that is actually what happens in this reaction. So if you look at option A is saying 4 moles of hydrogen ion, okay, is formed, 4 electron is actually, you know, added there to have what? 2 hydrogen. So at the anode, don't forget what we have is water is what is being what? It is what is being what? Oxidized, okay, to eventually form oxygen gas and that. So if you look at option B, we have 4OH minus this, okay, yes, then we have to give water addition of oxygen, okay, so oxidation is taking place here, water is being oxidized here, yeah, to produce, we have 4 moles of OH minus, and then we have 2 electrons. Then we look at that, so which means water is produced here. Then here we have 2OH minus 2E, then we have this happening here, okay, no, so this one is eliminated because this is not water, it is water that has been oxidized. So the only ones we have water being oxidized is option B and option D, okay, they look alike. We have water here and oxygen here because oxygen is being added to that. So oxidation takes place here at the anode, okay, at the anode. Then we have, look at the difference now. We have here, we have 4 moles of hydroxyl ion here, then plus 2 moles of hydroxyl. So you can't have, you are adding 2 moles of hydroxyl with 2 moles of hydroxyl. Then where is the electron that was what? That was you know, giving up, okay, at the other point that is added to this point. Don't forget, reduction is what? Gain of electron. So there will be gain of electron at the cathode where there is what? Electron, where reduction is taking place. Okay, don't forget the copper ion 2 plus will be what? Will be reduced to what? To copper metal, which is the solid metal at the cathode, okay, while at the anode water is being there. So this cannot be. So option B say 4 moles of OH minus plus 4 electrons, okay, that I needed to form water here and then this oxygen. So which means the correct answer here is option B. Now let's move on to question number 42. We have sodium carbonate reacting with HCl, okay, to form salt, water, and carbonate. Of course, whenever a carbonate, okay, metallic carbonate reacts with an acid, there are always 3 products. Salt will be formed, water will be formed, and CO2, carbon dioxide, will also be formed because it's a carbonate that is being what? That is being reacted with acid, okay. So the question says how many moles of sodium triazocarbonate form? Of course, we also agree that this is a neutralization reaction because this is a base, this is an acid, okay. We have salt and water. The CO2 is coming because we have a carbonate here, okay. So how many moles of sodium triazocarbonate form are there in a 25 cm cube solution which require 10 cm cube of 0.6. So like I used to say, the first thing is what? Write out your given parameter so that will guide us to know what to do. So let's move on to the board. So that reaction there, let me quickly write the chemical reaction. Sodium carbonate reacting with 2 moles of HCl, okay, to give us will give us NaCl plus H2O and then plus CO2, okay. So we have how many moles of this? We have 2 moles of this, we have that. So that's all about that. So which means that, in other words, we are saying that sodium carbonate plus 2 HCl to give 2 of this. Of course, this is solid, or you can have that, you can have it in aqueous if it is in solution. So aqueous solution, this is aqueous also, we have this and then we have that. So if you look at it, the equation is balanced. So which means this is ratio 1 to 2. In other words, number of moles of acid is 2 here because this is the acid, and then we're also giving number of moles of the base is 1. So we need that. So we're told that how many moles of sodium triazocarbonate 4 are there in a 25 cm cube solution. 25 cm cube solution, okay, which require 10 cm cube. So how many moles of sodium triazocarbonate? So which means that sodium triazocarbonate, we need the concentration of that base, okay. Then because it is in the concentration, we get our what? Number of moles, okay, because concentration is what? Number of moles in 1 dm cube. So we have that in 25 cm cube. So we have volume of base is actually 25 cm cube, okay. What else were we given? Which require 10 cm cube of 0.05. So we have volume of acid is given to be 10 cm cube, and then we also give it the concentration of acid to be 0.05 mole, okay, per dm cube, mole per dm cube, okay. So that's all that we have there. So to neutralize it, it shows that this is a word neutralization reaction to give that. So, and of course, we have CB, VB, CA. With your volumetric analysis, you know that there's a relationship between all of these together. And they say using the formula, okay, which is CA, VA, all over CB, VB equal to what? NA over what? NB. Okay, if you cross multiply that, we're going to have CA, VA, and B, okay, equal to CB, VB, and A, okay. But what we need to find here is actually CB, okay, CB. So we can make this summate of relation of the formula CB. So by dividing all through by what? VB and A, VB and A, okay. So when we multiply, this cancels this cancels this. So we have CB eventually will be CA, VA, and B all over VB and A, okay. So let's plug in the values we have now to make it easier. So we have CA, concentration of acid is 0.05 multiplied by volume of acid is 10 multiplied by number of moles of base is 1 all over volume of the base was given to be 25 cm cube multiplied by number of moles of acid is of base, okay, number of moles of acid is actually 2. So by the time you multiply this, we're going to have let me divide it this way. So that will be 0.05 times 10, okay, that will be 0.5. So we're talking about CB, okay, that will be 0.5 divided by 25 times 2, that should be 50, okay. So if we move this that way, will be that will be 5 all over, add 0, that's 500. We are trying to solve with that calculator, okay. So 5 over that, so this will be 5 here 1, 5 here 1, so that is 100. So 1 over 100 should be equal to 0.01 12001, yeah, 0.001 what? Mole, okay, per what? Dm cube, mole per dm cube. So that's our answer. So I know a lot of students will be asking, but we're asked to find how many moles, okay, how many moles of solution. So if you were told that the concentration is 0.01 mole per dm cube, it means that 0.01 mole, okay, of this base will be dissolved in 1 dm cube. So if it is dissolved in 1 dm cube, so it means that this is the mole that is dissolved in 1 dm cube. So it's the same thing by saying that your answer is what? 0. So don't get it twisted by saying, but what we got was actually concentration of the base instead of what? Getting one number of moles. It is actually the number of moles, okay, of that substance that is dissolved in 1 dm cube. That's what your concentration is. So you can say, just split it by saying 0.01 mole, of course, is the number of moles of the base that will be dissolved in 1 dm cube. So this is number of moles, 0.01 mole. Let's move on to the screen. Option A says 1.00 mole, 0.100 mole, 0.010 mole. The option D is 0.11. So the correct answer here is option C. Let's move on to question number 43. If the heat of combustion of hydrogen is minus 285.8 kilojoules, which means the heat of combustion. Heat of combustion is the amount of energy, okay, that is released when a substance is burnt in air. When we say air, we're talking about oxygen, okay. When the substance is burnt in air, what we have is what? The amount of energy that is released at that point is what we call the heat of combustion, okay. And then we're asked to find the heat of formation of water. When we talk about heat of formation has to do with the amount of heat that is released or that is absorbed. It depends, okay, that is either released or absorbed when the constituent elements, okay, of a substance actually react together to form what? To form that particular water. But we are talking about what? Heat of what? Formation of water. So we can write out a chemical reaction. Usually there's a formula we use. We said, let's look at the board. The change in heat of combustion is usually equals to change in heat, okay, of formation of water minus change in what? The heat of formation of what? Hydrogen. Usually we know that the reaction is actually between hydrogen, okay, let me write that here, hydrogen reacting with oxygen, okay, to produce H2O, water. So we can have moles of oxygen here can react to give this. So it's ratio 1:1 to form that. So that will be balanced. So we can rearrange this actually. Okay, we can rearrange this to be, because we have to find the heat of formation of water, which is this. So we can say heat of formation, okay, of water, H2O, is actually equal to heat of combustion, okay, of course, because if we move this way, okay, it becomes positive heat of formation of hydrogen. At this point now, heat of formation of hydrogen will be 0, okay, because it is not hydrogen that is being formed here, so it is what? Water that is actually being formed. So the heat of combustion, we are already given the equation to be, we are talking about heat of combustion of hydrogen here plus heat of formation of that. So heat of combustion was given to be negative of hydrogen was negative 285, okay, 0.8 kilojoules. So we have it plus oxygen. This is what? Is actually what? Is actually 0. So if you solve that, you still have 285.8, okay, kilojoules. Okay, that's what we have as the heat of formation. So because the heat of formation of water is 0, so which means in other words, the heat of formation of water and heat of combustion of hydrogen are also equal to what? Negative, that because there's no water hydrogen that is being formed at this point. So it is what we have is negative 2 times that. If what we had were actually 2 moles of this, then it's going to affect this. We multiply 2 by this. So we'll be having 2 times minus 285.8, you'll be having minus 571 thereabout. But we have what? Just have mole there, which is 1 mole of that. 1 mole of hydrogen is what we have here, okay. Then we have this. So this is still minus 285.8 kilojoules. So based on that, the correct answer here is option C, minus 285.8 kilojoules. Now on to question 44. Sulfur 4 oxide, potassium permanganate reacts with water eventually to form what? Sulfate. Of course, that is K2SO4. Then we have MsSO4. Then with this. So in other words, we are saying that this reacts with this and this to give us this. So in the reaction above, the products give a what? We have purple solution, we have purple precipitate, we have colorless precipitate, we have colorless solution. First, a precipitate will not be formed because, okay, first of all, this is sulfur 4 oxide, and then we have permanganate, okay? This is a redox reaction. When we talk about redox reaction, there's reduction taking place here, and there is what? There is oxidation taking place here. Yes, don't forget that here now, sulfur 4 oxide is acting as the reducing agent here, while KMNO4 is acting as the oxidizer. Of course, it's a strong oxidizing agent, okay? So it's oxidizing agent. So in oxidizing agent, don't forget, in oxidizing agent we usually undergo reduction, while reducing agents we usually what? Undergo oxidation. Don't forget. Oxidizing agents we undergo reduction, while reducing agents we undergo oxidation. So at this point now, this KMNO4 will become, which is an oxidizing agent, will become reduced, okay, from here to what we have here as this permanganate. Yes, here as what we have here, okay. It's reduced from here to what we have here, and then because this one was originally having a purple color, that's the initial, color of this permanganate, okay. Once it is being reduced, okay, to manganese ion, it becomes what? Colorless. And again, this one also, this is the reducing agent now, will undergo oxidation from here to what we have here as the sulfate of this. Is going to be from sulfur 4 oxide to become what? Sulfate, okay, which is positive. So there's an oxidation that takes place at that point. So in other words, in summary, we are saying that the initial is a redox reaction. The initial color of this, which was purple, eventually turns colorless because it has been reduced from what it was eventually to be had positivity. So if you do that, option A says purple solution. It's not going to be precipitate because it's going to dissolve in it. So you have a solution. So we have purple precipitate, colorless precipitate, colorless solution. It is not purple at all. So these two are eliminated. It's not going to form precipitate, but it's going to be a solution, a colorless solution. So the correct answer is option D. If you have any question bothering you at all on all we have done so far, please feel free to ask a question. All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to ask your question and solutions will be provided within the shortest period of time. Now let's move on to question number 45. In diagram above we have gas X, of course, is being formed here. You can see we have chlorine water here, and then we have sunlight. Okay, it's actually what is subjected to sunlight. So something still happens here. There's a reaction that happens there. So which means that when the sunlight is subjected, the experiment is subjected to sunlight, there's a reaction that takes place there. So what happens here? There's chlorine water is what we have here. So let's look at the board to see how the reaction was initiated. Okay, the initial reaction is actually between chlorine and water. Okay, because we have chlorine water there, you can see that. So when chlorine reacts with water, we have hypochlorous acid. We have hypochlorous acid there, which is HClO, okay, plus HCl will be formed. So when this is formed, what happens? Don't forget, this is taking place in the presence of what? Sunlight. Okay, so once this is formed, this hypochlorous now is formed, it will now undergo decomposition. Okay, it will decompose. It will undergo decomposition reaction by breaking down into HCl. Okay, and then what we call oxygen. This oxygen, you can see it. This is the the atomic form of oxygen. Okay, usually oxygen is supposed to be O2. Okay, so that's why we put this in this kind of bracket. Okay, so we call that nascent oxygen. Okay, we call this nascent oxygen. Nascent oxygen is just the atomic form of oxygen. Okay, nascent oxygen. Okay, which is very reactive but unstable. It's very reactive but unstable. So for it to be stable, we have to react with another oxygen. Okay, I'll put that here to show that it is nascent oxygen. We have another oxygen to give us the oxygen. What? This is the atomic. So this is the stable form of oxygen. So don't forget, this was discomposed to this and this to form the nascent oxygen. Okay, then this reacts with this. So which means that, in other words, the overall reaction is actually, when we say overall, we are adding this to be this. So we have Cl2 plus H2O here on the left hand side to produce HCl, because this one has been decomposed already. Okay, to form HCl and then oxygen that we have here. So we have HCl and oxygen that is formed. So you can balance your equation. 2 of this, that is 4. This is 4 hydrogen, 4 hydrogen, this and this. So in other words, the products are hydrochloric acid and oxygen. So let's look at the option we have there. So this is hydrochloric acid, and then we have oxygen. But the question says that what happened? Let's look at the options. Say the diagram above, gas X is what? Gas X is what? We just saw that it is oxygen that we have as the gas X. So we have hydrogen chloride there, and then we have, so the gas that is being produced at this point is what? Oxygen. We saw that in the reaction. So option A says hydrogen, chlorine, oxygen. So the correct answer is option C, oxygen. Do you have better explanation or better steps to solving some of these questions that we have touched so far? Please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the solution you wish to share. Now let's move on to question number 46. We have a diagram here. We have ammonia gas here. So you can see that is the vessel there. So which means the ammonia gas is being produced here. Then we have quicklime. Of course, your quicklime is your calcium oxide. Okay. And don't forget that calcium oxide is a drying agent. What is it drying up here? So which means that for it to be drying, that means this gas actually has a content of water. Okay. So which is there. So which means that quicklime is going to take off water. So which means in the product, we are going to have water. We are going to have ammonia gas, okay, in the product. And then because we have quicklime here, which is calcium oxide, so we should also have a calcium salt, okay, as this mixture here, okay, so that it doesn't react. Because if we have used the sulfuric acid definitely is going to react, okay, with the ammonia, with the water that we have there and the ammonia. So which means that at this point, Y now, you applied it to Y, and then what happens? We are trying to react. So now in the diagram above, mixture Y is what? Ammonium nitrate. well, of course, because we have ammonia gas being formed, so which means this mixture must contain ammonium salts. Okay, so we have ammonium nitrate, ammonium chloride. Don't forget that chloride of ammonium usually is can react. Let's see, if you subject it to heat, yes, you can have ammonium dioxide. So now we have all of them having ammonium here. So we want to look at the one we are going to eliminate now. Then reacting with what? Calcium sulfate. Calcium sulfate, yes, we have a calcium here, but we are talking about sulfate. This sulfate, okay, actually is going to what? Is going to react here with this ammonia that we have here. So definitely it cannot be this. Okay, option B says we have ammonium chloride, yes, reacting with sodium nitride. Okay, this sodium nitride, like this NO2 now, don't forget we have H2O will be formed because we have a quicklime here that is acting as a drying agent. Okay, so that's going to also react with this, so it cannot be B. Okay, let's look at option C, ammonium nitride, okay, reacting with sodium sulfate. Again, this is a sulfate again. Okay, so it cannot be because it's going to form H2SO4, okay, which is sulfuric. Yes, though it's a drying agent also, just like this quicklime, but it's going to form a reaction. It's going to react there. This reaction is actually what we call a double displacement reaction. Okay, there's displacement in two places. Look at this option. This says ammonium chloride plus calcium hydroxide. Calcium hydroxide, don't forget, is your lime water. Okay, yes, we have lime water. If lime water reacts with ammonium chloride, yes, we can have what? Ammonia gas can be formed. Yes, and then there's not going to be any reaction because we have water that is being generated in this product. Because we have quicklime, you must understand what the function of quicklime is to what? To act as a drying agent. So which means we have what? Water molecule. So out of all of this one now, where we have water molecule being formed, the way you can have it is actually the possibility of having it is in this. Let's look at the board to see how the reaction looks like. So we have ammonium chloride reacting with calcium hydroxide to form calcium chloride, okay, ammonia gas, and then water. So the quicklime is acting, like I said, it is double what? Displacement reaction. We have ammonia here, we have ammonium here, and chloride. Of course, you can split this to be ammonium ion, Cl minus. Then you have calcium ion, that's 2 plus. Then we have OH minus. Then, so which means that this man here, NH4 here, we can have this calcium here can actually react with this, of course, positive and negative, okay, can react together to form our calcium chloride, because this is positive too, so the two comes here, okay. Then because we have NH4 here, so we can actually have, this is OH left here, so this OH is left here, one hydrogen can come up from here, okay, to react with this OH to form our what? Our water. And then we have NH3 left here, okay, NH3 is left here, which is our ammonia gas, which is this. So you can see the three of them form in that point where we have. So let's move on to the screen. Option A says this. So the correct answer here should be option D. Ammonium chloride reacts with calcium hydroxide, okay, to form calcium chloride, ammonia gas, which is what we have here, okay, which should be dried by this quicklime, which is calcium oxide, to be able to form that, and then the water is removed. So the correct answer is option D. Now let's move on to question number 47. Okay, we have a structure here. This is the structural formula, and the question says the oxidation of the compound above produces what? First, we must identify what this compound is before we can answer that question. We have this is a carbon atom. We have OH group here. Okay, we have CH4, so which means this is an alkanol. Okay, because we have OH group here. Okay, hydroxyl group attached to this carbon atom. So, but we must understand first what type of alkanol is this, because it says the oxidation. Now, before we answer this question, usually we have three types of alcohol or alkanol. We have primary alkanol, secondary alkanol, and tertiary alkanol. If primary alkanol or alcohol undergoes oxidation, two products can be formed. Either we form aldehyde or we form carboxylic acid, depending on the condition of that reaction. If it is a complete oxidation, okay, that takes place, if it takes place in the presence of a strong oxidizing agent like your K2Cl2O7 acidify that, will form a carboxylic acid, okay, which is what will form. But if it's other, so in other words, in summary, primary alkanol, okay, can undergo oxidation to form aldehyde, which is alkanal, okay, or carboxylic acid, primary. Secondary alkanol, we undergo oxidation to produce nothing else than ketones. When we talk about ketones, that's the "-one", they end with "-one", okay, like the ketones. So ketones, secondary alkanol, we undergo oxidation to produce or to form what we call ketones. And then while tertiary alkanol, in most cases, okay, under that conditions will not undergo any oxidation at or reaction at all, okay, though there can be some exceptions, but generally, okay, tertiary alkanols do not undergo oxidation reaction. So in other words, we want to identify now that we know what product we should have. If it is primary, we have either aldehyde or carboxylic acid. If it is secondary alkanol, we have ketones. If it is tertiary, of course, we are not going to have any product because the reaction is just on. So we have OH group, okay, on carbon this. Now on this carbon that is attached to this hydroxyl ion, we have another carbon atom which is a methyl group attached here, then another carbon atom attached here, then we have hydrogen here. So how do we now identify? Is it a primary? Is it secondary? Is it tertiary? If the hydroxyl group OH that makes it alkanol, if that is attached to the carbon, that carbon atom that is bearing this OH, the number of carbon atom that is attached to it, okay, will determine. If we have only, let's say we have just hydrogen here, okay, hydrogen, OH, this carbon that is carrying this OH has only one carbon atom attached to it, we will say it is what? Primary alkanol or alcohol. Now in this case, now this carbon that is bearing this OH now has this carbon atom 1, has another carbon atom attached 2. This one is not carbon, so 2 carbon atoms attached to this carbon that is bearing this, so this makes this to be a secondary alcohol. If what we have here was CH3, there's another carbon here, so if we have this carbon that is bearing this OH if it has CH3, like say we have CH3 here, so we have carbon here 1, carbon 2 here attached to it 2, carbon here attached to it 3. If we have 3 of those carbon attached to this carbon that is bearing this, it will be said to be a tertiary alkanol. But in this case now, we have this carbon bearing this, just have carbon 1 and carbon 2 attached, so 2 carbon attached to it, so that means this is secondary alkanol. And then we said oxidation of secondary alcohol or alkanol usually will give rise to what we call the ketones, okay, ketones. So let's look at the options we have. Option A says 2-butanone, option B says 2-butanal, option C says 2-butanal, 3-butanal, option D says 3-butanone. Of course, the ketone will always end with O-N-E. So we have, this is butanal, this is aldehyde, so it cannot be. So option B and C are eliminated. So we have option A and option D, okay, as possible answers. So let's look at the structure again. It says 2-butanol, 3-butanol. So we are saying that on what carbon atom, okay, of course, if we say butanol, we have 4 carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1, 2, 3, 4. Now this is a butane, okay. Then the OH that is on it, on what carbon atom is it? This carbon atom, this is carbon 1, okay, this is carbon 1, carbon 2, carbon 3, carbon 4. So this is carbon 2. So on carbon 2, that is where the OH is actually. So that is where the reaction is going to take place. So this should be 2, because it's on carbon 2, 2-butanol. 2-butanol, not 3. The OH is not on carbon 3. Or it is not, so it's on carbon 2, so it should be 2-butanone. So the correct answer is option A. Now let's move on to question number 48. We have different structures here. The question says 2-methyl-but-2-ane as the structure was. So what I just want to do is I want to draw my own structure, then I'll compare my answer with what we have here, so to make it easier. So let's move on to the board. 2-methyl-but-2-ane. 2-methyl-but-2-ane. Of course, you know that this is the aspect of organic chemistry, okay? Of course, the easiest part of chemistry, okay? It's easy because it's just direction. I know someone might be saying it's the toughest, but it's easily the easiest part. So let's look at the structure of this. We have 2-methyl but 2 in. So what you start up with first is to draw your parent, the parent name, which is the parent carbon chain, the one that has the highest, which is always the one that ends here. Okay, so we have both. Both means that what? We have 4. Okay, so we have 4 carbon atoms. So I'll draw that out. 1, 2, 3, and 4. Okay, now we are not done yet. We've just done the both. Then we have 2, and then we have in. The in is meaning that what? It is an alkene. Okay, and alkenes usually are what? Carbon double bond. So which means that there's a double bond on this point. But at what position is it? Is it here? Is it here? Is it here? That's why we have what? 2 here. So which means that the double bond we have here should be on carbon 2. So I can count from here. I can count from here. Of course, it's 4. So it will still fall at the middle. So this is carbon 1, carbon 2. So this is where the double bond should be. So I will draw this here. Fine. So quite easy. So we are done with this. So the next thing now to draw what is to 2-methyl. So that's the functional group. Now, so we have a methyl group as a functional group. Okay, that is a substituent now that is added to on carbon what? On carbon 2. So we count again. Carbon 2. We have carbon 1, carbon 2. So on carbon 2 here, I will draw this, or you can draw it here anyway. Methyl, which is what? CH3. Okay, so but you must count to ensure that it observes and follows the rule. Carbon must not take more than 4 bonds. Look at this carbon here. 1, 2. This carbon has 1, 2, 3, 4. Okay, that's satisfied. So this carbon atom has 3 already. Hydrogen, if you expand this would have been 1, 2, 3. Okay, so this is 1, 2, 3, 4. So this is also certified that. So we have CH3 here. So let's look for other ones. So this carbon atom has 1. Okay, so we have 2, 3, and then 1, 4. It must be 4 anyway. So we have, this is 1 for this carbon now. 1, 2, 3. So it has 1 more, 4 hydrogen. Then this carbon has 1, 2, 3, and 4. Okay, I think that is all now. So, but we can condense it instead of, because I'm sure we didn't have it that way. So let's see it to condense. So this is C1, 2, 3. That means CH3, 3H here. So we have this attached to carbon here. There's hydrogen here. So we can have this hydrogen here if you wish. Okay, then we have a double bond here. Double bond here. We have carbon here. This carbon here. This carbon atom has attached to it CH3. Okay, and then we have this last one bonded to carbon here. How many hydrogen? 1, 2, 3. That is CH3. So this is the structure of 2-methyl both 2 in. So let's look at the screen. Let's go from option D. CH3 here, CH here, double bond. We have carbon here. We have CH3 attached to it. Yes, and then we have CH3. Yes, this is the correct answer. This one here we have double bond on carbon 1. So this would have been 1 but 1 methyl. It's not. It's even on carbon 3. That's carbon 2. We have the methyl group. So this is not correct. Look at the positioning of the what of the double bond is between carbon 1. It's on carbon 1, but the name befits that what the in should be on double bond should be on carbon 2. So which is this? So the correct answer is option D. So let's say option D is D. So the correct answer is option D. Question number 49. We have option A, B, C, D. What's the question? If I say which of the following functional groups will give gas bubbles, okay, when treated with a saturated solution of sodium hydrogen triisocarbonate 4. Once you see this, sodium hydrogen triisocarbonate, a carbonate, okay, usually we know, just like a confirmatory test, when an acid reacts with bases, salts and water are usually formed. We know that. When an acid reacts with metals, hydrogen gas must be given off. We know that they are confirmatory tests. So whenever a carbonate salt reacts with an acid, CO2 must be given off. CO2 must be given off. So it is just as sure as 1 + 1 is equal to 2. Okay. So this reaction, we don't even need to waste much time because we're told that which of them will give gas bubbles, okay, when treated with saturated solution of what? Sodium hydrogen triisocarbonate 4. So which means there's a carbonate here that will give gas bubble. So of course, what gas bubble will be given off from carbonate is the CO2. There's no doubt. Let's look at the board to see what we have. So if we have, whenever acids, okay, let's say we have RCOOH, okay, react with a carbonate. Let's say we have from there we have sodium hydrogen carbonate, that's bicarbonate. Okay, what must be given? Will be given R, okay, COO, okay, this is where the hydrogen is dissociated so that sodium can come in here. We have Na, okay, reacting with, of course, we are going to have H2O, water will be formed, and then we have CO2 reacting. Don't forget that this is like a base, this is acid, okay, we have a salt, water, but we have gas must be given up because it's a carbonate that we have in there. Of course, you can balance the equation of reaction. The point is that there is bubble of gas here, okay, which is CO2 that will be formed, okay, and then this is salt, and then this is water that is formed. So in other words now, this is what we are looking for now. You say which of the following functional groups? So which functional group has, so this is the acid now. The carboxylic acid reacting with the bicarbonate to give off what? Carbon dioxide, which when you bring closer to lamp water, you can see it turning what? Milky. So let's look at the options we have. Option A says NH2. Nope. This says COOH. Of course, this is your carbonate. You can have out here. So this is what? Your carboxylic what? Acid. Okay. Then this is OH, this is alkanol, and then this is your alkanal. So which of these is? The correct answer is the carboxylic acid, which have RCOOH. If you react it with a carbonate, CO2 will be given off. So the correct answer is option B. The correct answer here is option B. Question 50. We have a diagram here. Okay, this is the reaction curve. We can have it here. We have, this is the reactant here, A plus B. This is the reactant here, eventually going up to form. We have where the product is. This is C plus D here. Okay, so you can see we have two curves here. There is one that has broken lines, like dotted lines. That is usually the one that is represented with the catalyzed. That means this reaction took place. This reacted with this in the presence of a catalyst. So it's a catalyzed reaction. Okay, and then we have it at this point. The second one, which one is without use of catalyst? This one reaction will still go on to completion. Okay, so here we call this activation energy, and we know that activation energy, like I said, is the minimum amount of energy that is needed for a chemical reaction to take place, to occur. But in a curve like this, usually how do we determine what the activation energy? Because we're told that in the diagram above, the respective activation energies for the catalyzed and uncatalyzed reactions in kilojoules. So we want to find the activation energy, and we know that the transition state is this point where that electron, when it says transition, something has moved on, energy has been given off. Okay, so energy that made that reaction to come to completion is what we call transition state, the energy of the transition state, and then we have the reactant energy. So in other words, we are saying to find activation energy, we are looking at the difference between the transition, this is where this point here is the transition state, okay, energy difference between here and the energy of the reactant, not the product, reactant. So you can just have it this way. So which means from here to here is the activation energy. Okay, usually we write EA. Okay, activation energy for the the catalyzed, and then if it's the catalyzed, we have it from here moving this way, still at the reactant energy. Let's go to the board so that we can solve that. So we have activation energy is said to be energy of the transition state minus reactance. Usually I will just represent with symbol EA. Activation energy is equal to transition energy state, okay, minus reactant energy. Okay, so if you look at the curve very well, okay, let's look at the diagram. If you look at the diagram very well, let's see what we have for the catalyzed, because we're told to find catalyzed first. For the catalyzed reaction, okay, let's see what the catalyzed reaction activation energy will be equal to. Let's look at what the transition energy is. Okay, let me clean up this so that we don't. Okay, so the transition state, this is the catalyzed reaction. You can see it's been labeled here. So this is the point here. So let's trace that here. Just extrapolate it here to this point here. So if here is 40, here is 50, so that means the half here will be what? 45. So that means at this point, this is 45 here. For this is transition energy will be 45 minus the reactant energy. Okay, let's go back there. Reactant energy, this is the point. Don't forget, we are still talking about the catalyzed. So it's this point here, which is here. So if here were 10 and here is 20, so it is 20 because this is 30. So this is 20 and here is 10. So 10 here, 20 here. So the middle here should be what? 15. So here the reactant energy should be 15 here. So we have it here to be 15. So by the time you subtract 15 from 45, we have 30 kilojoules. So let's look at the what? Uncatalyzed reaction. Okay, of course the activation energy still remains. Transition energy, the energy of the transition state. Okay, let's look at that. For that we have so we are not considering this one again now. So what we are considering now is with the uncatalyzed, this point here. So that's the transition state now, the energy. So you can trace it here. Let's say we have 50 here, while the reactant energy, of course, still the same here, is still 15. So we have 50 minus 15. So let's solve that. Let's go back here. We have 50 minus 15, so which is 35 kilojoules. So which means the activation energy for the catalyzed reaction is 30, and then for the catalyzed is what? 35. So 30 and 35. Let's go back to the options we have. 30 and 35. We have 45, 50, 50, 45. Okay, 30 and 35. So option C. So the correct answer actually is option C. I believe you enjoyed this content because I really did solve those questions. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.